Hello, this is a list of nodes which we are going to discover along this lesson, and also we will use the nodes that we already studied in the previous lesson. These nodes are also very basic and they will often be useful to you. Okay, now let's create an empty geo node and jump into it. Then create a line and change the line direction along X. Put a 10 for line length and 200 for points. If points are not displayed on your viewport, just click on this. Okay, let's drop down the attribute VOP. Connect to it the geometry. Then dive inside. The first thing we need is a getVectorComponent node, let's drop it down. Connect position. Then select the first component. This means we have extracted only the X component of this vector. Let's also create a setVectorComponent. Connect position. Then connect the extracted X component to here and select the second component. This simple setup means that we drive the Y position with the X position. Well, let's connect the edited position to the output P. Here we go, we get a linearly growing line. Instead of linear growth we can do something more interesting. Let's create a sine function. This operator performs a sine function. The input has to be radians. As you can see, the curve is deformed as a sinusoid. In order to change the frequency of sine, you have to multiply some value before sine node. Let's create a multiply constant node. Look, changing the multiplier the frequency changes. To offset the sine, we just need to add some value before sine node, let's create an add constant. Take a look, the sine is shifting. These two nodes can be replaced with one single node. Let's remove them first, then create a multiply add constant instead. This operator will take the input value, add the pre-add amount, multiply by the constant multiplier, then add the post-add amount. As you can see, with this node, we can control both frequency and offset. We can even replace these two nodes with one node. Let's delete these two nodes and create a trigonometric functions instead. This operator performs a variety of trigonometric functions. The argument must be expressed in radians. Take a look, the frequency and the offset are already built in it. You can also change the function type. Here you can find all trigonometric functions. Of course, they also exist as a separate nodes. Now I will show you a few of them. Here they are, cosine and tangent as separate nodes. Okay, let's get rid of them. In case if you want to change the amplitude of the sine, you will need to add the multiplier after the function. Let's create a multiply constant and connect before the function. Look, changing the multiplier changes the sine amplitude. Okay, let's go on. Now I want to introduce you to the clamp node. This operator clamps the input data between the minimum and maximum values. Since the default minimum value is 0, values below it become 0. Look, changing the min value we change the minimum allowable value, and changing the max value we change the maximum allowable value. Okay, let's delete the clamp, we don't need it anymore. Now I want to introduce you to another useful node, which is called absolute. This operator computes the absolute value of the argument. It can be used to convert negative values into their positive equivalent. As you can see, all negative values became positive. Let's turn this off and on, just to see the difference. To change direction along the negative y-axis, we can simply add a negate node. Okay, let's delete it too. Now I propose to complicate the setup a little. Create a fit range node. This operator takes the value in the source range and shifts it to the corresponding value in the destination range. Values outside the input range will be clamped to the input range. Let's connect to it the position along X. Look, in this case the source min is 0 and the source max is 10, so here we have to set 10. The destination min and the destination max we will leave as it is. In simple words, we took a range from 0 to 10 and squeezed it from 0 to 1. Now let's create a multiply node, then multiply sine amplitude by the destination range from 0 to 1. That's it, the amplitude grows linearly. To invert a linearly increasing amplitude, we can just swap the maximum and minimum. Let's temporarily make the destination range from 0 to 2. Now I want to change the linear growth and make it exponential. For that, let's create a power node. This operator raises the first argument to the power of the second argument. Here we go, we can control the sharpness of exponential growth. In this case, the maximum value increases because the range from 0 to 2. If we make the range from 0 to 1, the maximum value will not increase. Okay, now let's delete the power node and create a ramp parameter node. The ramp parameter node represents a ramp user interface. As you can see, the output of the ramp is a vector because by default the ramp type is set as a color ramp. Let's choose the spline ramp. Look, the output becomes a float. Okay, now let's give an input range to the ramp. Then multiply the amplitude by the ramp output. As you can see, the sine wave is gone because the spline ramp is 0 by default. The spline is promoted at the object level. Here it is. Let's tweak it and see what we get. As you can see, the spline controls the sine amplitude. Let's get back inside the VOP again. Now I am going to plug the output of the spline ramp directly here by passing through the sine deformation. We can also get rid of all these nodes, we don't need them anymore. Let's arrange the nodes to make the network more readable. Then jump to the object level and see what we get. As you can see, the line now follows the exact shape of this spline. Okay, let's jump inside again. Now I propose to create a spiral. In fact, all those nodes that we need to build a spiral we are already familiar. First, let's delete all these nodes except the getVector component, then create a float to vector node. Plug the output vector to P. Connect the extracted X component to the corresponding X input. Now let's create a sine function. Plug the extracted X to the sine input. Connect the output to the Y component. Now let's create a cosine function. Plug it to the Z component and give an input. Here we go, the spiral is ready. Finally, let's make the frequency and offset control by adding multiply add constant node before sine and cosine function. Here we go, now we can control both. Okay, that's all for this lesson. In the next lesson we are going to discover again a lot of new nodes.